And today, my plan is to introduce or reintroduce what is the status with NDN Certificate V2 with some ideas. I put a link to the certificate format and additional details about the certificate format. And as well on that documentation, there's additional things related to the certificate storage formats and so forth. And I will give you a few highlights of NDN a few highlights of the NDN Cert protocol, which also has its own wiki page and way more details than I can put on the slides right now. But I will be happy to talk more if you have questions. And I'll try. Okay, so for the certificate format V2, I hope most of you actually at least heard that we are switching to a new format. I no longer decided to put the old format just to highlight what we have in the new one. So the new one is effectively a data packet, which has name, meta info, content, signature info. The important things, kind of the name and meta information I used as before. There's a naming change with a few serious consequences, or not so serious. The major changes in the format itself are with the content part and the signature info part. So for the content part, it's no longer actually we put in the so we're putting too much information as part of the kind of this X509 information. We try to shuffle validity info as part of that. So it was harder for the applications to actually extract very valuable pieces of information that are necessary for kind of validating the validity of the certificate, for example. And those pieces of information we actually put into the signature info, so they kind of belong to the signature itself. And the things that we added, so far we just defined two of them. There is a validity period and optional additional description item. What's interesting about the current format is that we defined it to kind of signature info to include optional critical and non-critical components. So for, I think I put a little bit more details on that on the next slide. Okay, so that's all what I wanted to highlight about the format. So we have a content that just carries this X509 signature to be used in all those crypto libraries to understand how to do actual public key, public-private key operations, and all valuable information about the certificate itself, is carried either in a name directly. I mean, I'll show you in a second what is carried in there, or is carried as part of the signature information. Lan, do you have a question? No, okay. So let me move along. So for the signature info extensions that I just mentioned, so there is a critical, non-critical, and critical is if somebody put the critical extension as part of the optional signature info, is that if someone cannot recognize it, it has to reject that certificate. On the other side, if it's non-critical, such as this additional information, just kind of for people to understand what the certificate is about, or some association about the certificate. Then if the validator cannot recognize that one, then validator can simply ignore it. And we have adopted conventions, which is very similar to IPv6 convention for extensions, is if the last bit of this TLV type is 1, so then it would be a critical extension. If it's 0, then it would be non-critical. But again, I will highlight that so far we only have 1 critical and 1 non-critical. Hopefully we're going to have more as long going forward. So now this is the key part, and I think the major reason we actually have this seminar is about the new naming of the certificate. If you're familiar with the old naming, this will be kind of very educational, and if you're not familiar with the old one, then still be very educational. So for the new naming, we changed. It's kind of have a similarity with the old one, with a kind of several differences. First one is that this key component that existed in previous naming convention has a fixed position. So it's always fourth from the last, and kind of a component, like a set of the components that goes before the key component actually defines the, so what exactly it defines, it has several definitions. It can be called either certificate namespace, subject namespace, or sometimes we call it identity. So there are cool features of this naming, and these cool features are as follows. Kind of it's related to maybe a little bit logical view of certificate, key, and identity. So this is the full name of the certificate. If you strip the two last components, so issuer ID and version ID, it will become a key name. And if you strip two more components, it becomes identity. So kind of if you do the management, it's way simpler than in the previous conventions. So for just to give a few comments, issuer ID, it's kind of some identification of who exactly issued that certificate. In the current libraries, we kind of freely use some identification of what this certificate is about. For the self-signed certificate, I have put to just literally 4 characters saying self. For self-signed certificates, I forgot what exactly I put, but it's just some fixed string, just identifying something special about the issue. We probably need more understanding or more experience with that issuer ID to understand how exactly it will be used. And version is actually just the same as version before.
I have one question.
Yes.
So how this issuer ID is determined? So is it unique for a certain issuer?
So the idea behind this issuer ID is that we may have multiple hierarchies. So kind of you may have a key that is being certified by the parent key or something, and is certified by some other key that's not related to this hierarchy. And the idea was to issue that certificate in actual key namespace, but to somehow identify that is being signed by key out of the hierarchy. So the actual key that has been signed is always part of the key locator. It's just additional indication that something is different. So I guess you're asking about an LSR. If we're using, if our signer of the certificate is a part of the same hierarchy, so for example, if it's parent signing the child and so forth, then we can literally just indicate the parent. Like something very simple. It doesn't have to be unique per se. So that's my understanding of the issuer ID.
Yeah, so my question was that, for example, if a parent sign multiple child certificate, so in each of the child's certificate, the issuer ID will be same, right?
Yes, it can be even same across different signers. So like let's say my computer signs a child certificate for whatever, some application. I can put this issuer ID as a parent, and you can do the same operation on your computer and also call it a parent. So the only purpose of this identifier is to identify different types of issuers effectively. So maybe it's better be called issuer type ID. But no harm if you have a unique ID of the issuer per instance, not like either hash of the key that has been signed. So that's also valid, and I think the Indy was wanting to do that originally.
Yeah. So, so what is the use case of this issuer ID?
As I said, it's mostly for the cases for multiple signatures of the same key. So if you get this key signed by multiple parties, like by parent, by whatever, Alex, not related to anything else, by like Facebook, by Google, those somehow will have indication that it's a different signer of the same key. Because before there was no way to indicate that, the signer in the name. So we somehow assumed it would be just a different version of the certificate. And then there was a problem regarding that.
So it's actually application specific, right?
Yes, yeah. So just one example, in NDNS, we use word NDNS as part of the issuer ID because it's kind of using the NDNS hierarchy for the purposes of the key signing.
But nothing prevents my application to use issuer ID of someone else, right?
Yes, no problem. I mean, you may cause the problem to yourself at some point, but we need to first cause the problem and to understand it. As of right now, I don't see much harm or any harm at all. So just remember that we have this additional name component that needs to be filled. This is actually as part of the certificate generation. It's added in some cases. Some cases it's explicitly asked. And for now, you can literally put anything. Ideally, you try to put the same ID in the certificates you're generating. So kind of the version of the certificate is tracked for this key for the same issuer, like in case you want to do the revocation. Okay, so I hope I answered the questions. Not sure the answers were great ones. And yeah, I think we just talked about this. Is that actually a slightly different topic? So what the kiloketer identifies, this part does not change or did not change since the previous framework that we had. In previous framework, we also had the kiloketer to identify the key, not the exact certificate. But because we didn't have the issuer ID, so the kiloketer was certificate name minus version component. Right now, the kiloketer is actually certificate name minus 2 components, or simply name of the key. So that what is carried in the kiloketer. So the interesting part, and this will be explored as part of the NDNS, the issuer can be inferred by the validator itself, or like validation policy. And the version is implicit unless you have some oracle to know which exactly version you want to retrieve. And issuer can be also implicit, then you're just getting some version of this, or some version of certificate signed by somebody that you have no clue yet about. So, and that's the current model.
So I have a question. So what is the purpose of having both the issuer ID and the key locator? Because, so let's say for a specific...
Wait a sec. You issuer ID and key locator?
Yeah, because you said for a specific application, you can specify the issuer ID here. And if we know the key locator actually would know which application is trying to issue a certificate, in that case, so we know that that's specifically for a application, then why we still need the issuer ID?
issuer ID is part of the name. So what you can do, you can actually, so this is some engineering thing. Ideally, you would put the whole key locator is part of that issuer ID, because that's the main goal, is to identify in some way what that key locator represents. And the key locator is actually giving you the name of the key. So we could have went in the direction putting this key locator as part of the name, but it just a bit ugly.
Yeah, sure. And another question is, so issuer ID is, so let's say you said for a specific application, we can put an issuer ID here. So we know this key is issued by whom. But let's say for my identity, is there a case that my certificate is issued by two applications? So you need to set a different issuer for different applications. So I didn't understand this part.
Okay, so how many certificates you have?
In some case, not only one. We can have multiple authority to sign my certificate, but I mean, in the real case, do we need to have two applications to sign my key?
I still don't understand the question.
So you said for a specific application, you can set an issuer ID here, right?
I'm not sure what you mean by the specific application. So the issuer ID is for the cases when you want to distinguish different certificates for the same key issued by different parties. Okay, that could be at different applications. So if the key is multi-signed, you need to have a distinguisher in the name of in some way identifying or like distinguishing one certificate from the another.
Okay, yeah.
So we're not really using it right now because we're kind of limited in that sense. But given the key of some namespace, that key can be signed by, as I said, Facebook key, Google key, some other key. So those these certificates would have a format of /edu/cs/cs key, some key ID that this kind of stays always the same for all the different versions of the certificate. And then there's a component identifying in some way. So this part is still ongoing research. Who signed that certificate, and then the version is specific to that signer of the certificate. And then the key locator is actually identifying a specific key that needs to be fetched to validate that signature.
Okay, thank you.
More questions?
You can use the signing keys key ID here as the issuer ID.
Signing key ID. Yes. I mean, you can use anything. There are many options. So one option is literally to use the whole name of the signed key. So like duplicate the key locator. So that is one option. Another option, so key ID, not sure it would be a good option, but you can do that as well. You can use some fixed values. As already mentioned, for the self-signed certificate, you can simply use word self or just don't use anything. For multi-party signatures, like if you have a name of some specific entity, that can be just some short name of that specific entity. Like if it's signed by Google, it can be literally this small string saying Google. Again, these are new opportunities. I cannot give you a specific requirement how to use issue ID. So far we have very limited examples, and like those limited examples I already mentioned, like self and parent.
I'm just wondering how this component would affect validation. Do we need to change the validation rules for NLSR? That's something I think.
I actually have example.
Okay.
So it doesn't really change much, and the whole naming structure simplifies. But the validation rules simply need to assume there are extra components after key name. So that's the only thing. The only consideration needs to be done. But I literally have an example in a few slides later. Okay, so I wanted to add a bit more on new key naming, which is a little bit non-critical, but it's a change of the behavior or change of the status quo that we had before. And before, what we had was we had the concept of key ID, which was generated as based on a timestamp when things are generated, when the key was generated. So the default has been changed to be just a random number, but there's still so there's still an option to use the timestamp, and there are two new options available to get this key ID. So one new option is to use the digest of the public-private key. So this would be kind of tightly coupled with the actual content of the key. And by definition, it's supposed to be unique. And the other option is just a user-specified name. So those four options already exist as part of the library. Unfortunately, as I said, it's not part of the command line interface of the NDNCERT tools, but I already created a Redmine issue so we can track it and make it work. Okay, so this part is non-critical. I don't expect this to affect anybody. Maybe it will be a little bit challenging to, like in some web interfaces, to track down like the order of the issued keys, but we should be able to figure it out in some other way. Okay, and now this is related to Lance's question of how do we need to change the naming key. So because of this new naming, there are a few in big quotes, a few changes in the naming of some of the rules in the validator config. What I have not mentioned on this slide, there is actually additional change that happened, but that's just part of the validator config. I think, I originally had it on a slide, but I removed it. So before, the validator config understood the concept of command interest, and the command interest is the interest plus four components after the name that you're trying to sign. It's a timestamp, nonce, signature info, and signature value. The new version of the validator config, unfortunately, only understands concept of signed interest, and signed interest only includes this signature info and signature value. So for that, rules that related to command interest, for example, this is a NFD rule for local hub and local host registrations, simply needs to add the two components at the end. So they don't need to be processed in any ways. They just need, the regular expression needs to consider that they exist. Otherwise, they're simply not going to match. So that's one small thing that some of the rules needs to be modified. So the checker for the key names, so this is the biggest change that affects NFD, NLSR, and other applications. And I believe the change actually becomes, after this change, the things become simpler. And somebody can explain me why we had those rules, but the idea is because of the key component now has a fixed position, we don't need anything else. We just need to match that there is some whatever components at the end, like the three components is a key ID, issuer ID, and a version. Then there is a key component, and then there is whatever with identity if, in case we need to match it or not. So that's would be for the checker names, and a similar change in this hyperrelation key locator checker. So this is I took from testbed NLSR config, which had this complex rule. Okay, so maybe I ask Ashlish or somebody else, why did we have this complex and strange rule? Like, why did we need to exclude this key and LSR as first components, as given that the rest of the components has a fixed position? Do you have any reason for that?
Well, I think this excludes excludes names that contain multiple instances of the key component before the last key component. And same thing for NLSR.
But why? Like, what to do with that?
I don't know. I think Indy put in these rules.
I mean, I think I understand. So there was some relationship to this exclusion for the moving component, but if a position of things were fixed at the end, so then I don't quite see the need for whatever those exclusions. And in any case, so on the right is my proposal for the updated rule is simply remove all those randomness about exclusion. So anything, so it's supposed to match anything before last 1, 2, 3. Oops, and I actually made a mistake. Oh, no, sorry, it's not a mistake. So because it's a key locator thing. So key locator is just a key and a key ID, then an LSR, and anything before those 3 components at the end will be matched as part of the key. So there is nothing else needed. I'm expecting that this will simply work if we make this change. There are more similar changes needed than NLSR.com, but I don't expect any major problem. Okay, so I hope with this slide it's a very good summary of what needs to be changed. I think for NFD-conf, for our remote registration, so literally these 2 changes will be sufficient. So this is in one place and this change in 2 places. And NLSR, there are similar changes like this that and changes to hyperrelationship. And afterwards, things supposed to work.
Oh, I have a question.
Yeah.
So in for the last example, NLSR's hyperrelation, on the left, you are trying to, the first line is trying to match a certificate.
It's a key name, not certificate.
Key name, but so why does it have ID cert at the end? Maybe I'm
because
confused.
Before that was a part of the naming. So the old name for the certificate was blah 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 key blah 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 ID cert / version, and the key locator had exactly the same thing but minus version. So it had blah 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 key blah 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 ID cert. So that was part of the key locator. And now we have just blah 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 key and one component to identify these.
So this rule is trying to verify. I'm not sure exactly. I don't remember. What is this rule trying to do?
That's beyond me.
Okay.
So I just tried to literally copy what was in config file and just do a simple transformation. But for more meaningful understanding, we should actually go through the NLSR trust model, maybe at some other time, or an NFD call, and to see all those relationships between what we have a side key, I mean, there is a network key, site key, routers key, and individual instance keys.
Oh, okay. I think this is trying to verify that the LSA is signed by the right key. Is that right? So the LSA name is in the p regex field, and I think it's trying to check if you have this LSA, you need to look for that key in the key locator. Is that right? It looks like that's the interpretation. Okay.
Yes, so regex is the name of the data packet. So it starts with localhop, has the NOSR LSAs, and then so there will be these two sets of components extracted as a /1/2, and then they will be tried to match it to everything that comes before an LSR key and one component as part of the key locator.
Okay. All right. Okay.
John, I hope that's also clear to you.
Yes.
Okay. And Peter, have you been using Validator config?
Sorry, which config?
I mean, this rules in your application.
Oh, yeah, but for version 1.
Okay. Okay, so as I said, I hope the changes actually make things simpler. If changes make things more complex, talk to me, and I'll try to figure out why is it happening.
One more question. Maybe you already mentioned. I was late. There's no more KSK and DSK in the name. Name.
Okay. So let me about that part. So those indication was never, like at least I never thought that people will be actually using them for semantic reasons. So those were just a part of the ID. So it's part of the key ID part for human readability. I have added a KS key, DS key minus something. It's still possible to do the same thing with the new naming conventions. I just tried to remove this perceived notion of that those parts of the key ID should be used as part of the matching rules. So I consider all the previous rules that like this, had the regular expression as part of the name component of the key ID as completely wrong. So those not supposed to be. So this is supposed to be. Oops. I'm not sure you can see it in my mouse. Just any component. So it just should be ID, not key minus anything afterwards.
Okay.
So that was like a strange error that we had for quite a while. Okay, so there are a few consequences, I think. So that was a consequence for the Validator config. There's interesting consequence regarding the storage. For those who attended NDN calls, we already discussed this, and we had a few solutions for this. So before we had this floating key component, which also kind of were overloaded with the notion of where that key is authoritatively stored. So for example, as I showed on this slide, NDN key is stored somewhere that is announced in /NDN key, and then edu UCLA key is stored somewhere that announces like bigger names. Because right now we have this key locators key component at fixed position, we no longer can have this ability to store to direct that key to some centralized storage. Like it always will effectively go to your computer, and if you're running some repo on your computer, you'll be able to easily fetch that certificate. And we have a quick fix in works to effectively hijack all those request for the keys to the local repo in case that the repo actually has the corresponding certificate. And we have a few longer-term solutions. They're still in progress. So one of them is certificate bundle. I think I have one slide on this. Not sure we can make it. There is NDNS, PIP. So those solutions include modification of how certificate has been retrieved. So instead of just simply retrieve a certificate, there is additional machinery regarding of the retrieval. But I'm not planning to talk about this more. Okay. Okay, so that's last part that I want to mention about this format, about the name, and like a few serious consequences that we need to address. Now, just a few ideas of the new keychain and some ideas behind the keychain. So the new keychain, so kind of, this took us a longer time to do all this development because we bundled all the modifications together. So now we simplified the interfaces and abstractions. So we try to do the optimization for the in-memory caching of keys. As I put on a slide, everything is merged already, and we're kind of trying out to finalize other tools. So we have a command line tools to deal with all those things, but still some things may need to get improved. And we have ongoing to do to integrate security, those tools to actually generate certificates, sign certificate as part of the control center and Android, NDN Android. So it's kind of people can easily use those things.
So Alex, I have a question here. So now I'm implementing the keychain here in NDN Android. So here integration, what do you specifically mean?
So I meant, okay, so for the Android, it would be, it's part of the ID manager. Like this ID manager interface is supposed to integrate generation of the V2 certificates and effectively just use the keychain V2 interfaces to generate certificate. Plus ability to request certificate, that would be NDN Cert part that I will be talking later. And installing that certificate and doing some other part. So it's a very loaded task in this small to-do. Okay, I hope I answered your question, though it may not be directly.
Yeah, we can talk about the details later. Yeah, thank you.
So I just want to highlight a few things about the internal of the keychain. Oh, sorry, internals of the validator. So because that was another major change that we have done for the purpose of streamline all the implementation and make it more modularized and extendable. So first of all, we now, effectively, the validator now has three components. So one is the overarching validator interface, which is fixed and non-extensible. And we have a policy and the fetcher abstractions. Those are extensible, and I give you a few examples of what we currently implemented. So the policy, or validation policy to be specific, is the module that doing kind of very, which is not doing any crypto operations, but rather trying to figure out whether that data can be signed by that key just by looking at the data packet itself, at the names, at the key signature info field, including the key locator, validation, validity period, and other information. Then there is a component doing retrieval of the certificates. So there's multiple ways of how we can retrieve the certificate. So it's either we're doing the standard way, just expressing that interest to the network and hoping to get the result. So that would be the certificate fetcher from network. There is a certificate fetcher direct fetch, which we implement talked before. So retrieving certificate to validate data by sending interest to the face we receive that data from. Again, we have not really explored that in any applications yet, but that would be on immediate to do somewhere. The offline is just for debugging purposes, that you just don't do any fetches, and all operations are from the internal caches of the validator. And the certificate bundle is a fetcher, is to retrieve is kind of using a certificate bundle. So for validation policy, there is a similar set, I mean, similar in principle set of the policies. The most important one is the validation policy config. I forgot to put this on the slides, but this is part of kind of the overall picture. So the old validator config as a class, as a interface, is actually stays the same. It's just is realized in a completely different fashion. But if your application, like I think in NFD we did extremely minor changes to actually accommodate the whole validator 2 framework with the validator config, and validator no, that was like just doing no validation. One thing that I wanted to mention, because that triggered by NLSR discussions, inside the Validator 2.0, we actually have a certificate storage, and actually multiple certificate storage, 3 of them. One for unverified certificates, so those can be added by anybody, by any process at all. And those will be cached for the freshness period time. And we can retrieve, we can delete them. So there's 2 additional storages, one for the loading and resetting anchors, and caching and resetting verified certificates. So anchors will stay with the validator forever. So that's kind of a difference. So anchors are stored in semi-permanent storage versus and trusted versus verified certificates are stored in a cache and verified for the time of the freshness period again, and kind of will be re-verified at some point in the future. And we also have the built-in limit on the validation depth, can be modified by the default value that we currently using is at 25. If anybody has a longer certificate chains, okay, let me know. I just never heard about that yet.
Can I do a clarification?
Yes.
What is the freshness period? Is it not the...
That's the one that overloaded the meaning. So this is this one.
Okay. Okay.
So I'm guessing there is a concern, a comment of the overloaded meaning of the freshness period.
Right.
I would agree with that, but this is what the current state of the affairs is. Because we want to cache for some time, and that was the amount of time, I mean, the only number that we can put.
So there's no point of removing it if the cache is not full, right?
No, there's actually a point to remove that. So for the reason to remove the certificate is because we may expect a new one. Sorry, wrong statement. We may expect a newer version of the certificate to be issued, and by newer version with a different validity period or a rejection of that certificate, or
yeah, I think the freshness period is not the validity period. That's where I get confused.
It's not the validity period, but it's kind of the freshness period for the certificates defines the time, how fast, how quickly somebody can revoke the certificate. or revoke the key actually. So I have to use the correct terms. So given the key, it can be in multiple states. It can have a valid certificate and can have a rejection of the valid certification. Like if the rejection of certification has a better version number or issued later, then that key is invalid.
Well, I think maybe this really need to be discussed later. I think I'm a little confused. Before this, just the key is in a valid period or otherwise expired or otherwise revoked. I cannot tell what this freshness period is doing. I think you cannot define to say within 1 hour, you cannot revoke a key. That's not exactly right. I don't think revocation should be subjected to a time constraints. Oh, you think it should? So, you know.
I mean, there has to be some time to, so revocation can happen in 2 ways. One is based on the validation period, but then there's kind of a passive one.
That's not revocation, that's expiration. That's again,
yeah, so the revocation is kind of the active process. So somebody has to notify somebody that the certificate is no longer, or key is revoked.
So therefore, when we talk about short-lived keys, it should be the shorter validity period, not this freshness period.
But you understand, like we have, NDN is a pull-based model, the consumer-based model. So the consumer has to have some understanding of when to try to get a different version of the certificate. But because it got one version certificate a year ago, it's still in validity period. But
I think your validity period is not right to my understanding. But again, I think this deserves a different, longer discussion. You cannot define your validity as a 1 year, and you think you're going to actually change it every other week. That doesn't sound right.
Otherwise, anyhow, let's talk about this some other time.
Yeah, I will take a note.
So a few things, I already actually made this comment about the important notes. I'm not going to mention it. But I just want to say that in validation policy, it actually can be stacked, and it is stacked as part of the validation config. So it's kind of 2 separate policies stacked together. And if you define in some other policy, you can actually stack on top of those 2 things and do something interesting. But I'll go forward. I'll skip this one, and in the last 2 minutes, I just want to go over the highlights of the NDN Cert protocol. And kind of the idea is this streamlined version of the old certificate management infrastructure that we had. So the one that we had was primarily it's kind of for the testbed certificate specifically, and was relying in most cases on IP exchanges like HTTPS exchanges or HTTPS exchanges to submit your request and retrieve the certificate and do some other things. So with the new protocol, which inspired by the Let's Encrypt to some degree, we try to make the certificate a request of the certificate or becoming authority of some namespace as streamlined as possible. So on this picture that I show here is a kind of to highlight the fact that there are 2 specific cases when a certificate can be issued or can be requested is from local applications asking for whatever some centrally managed set of the certificates on the same computer. So it's one case that we are considering, and the kind of general case when either application on a computer or that's the central place that is running on the operating system, like this ID manager, requesting certificate from the remote nodes. So kind of the second thing that I'm talking about is effectively our old test-based certificates, but this can be actually some other things. Again, I want to highlight that that with the NDN Cert protocol, anybody can become an authority. We still use word CA for the namespace, and for that purposes, you either generate self-signed certificate and kind of become a local trust anchor for whoever local environment or local applications or your local home environment, or you obtain some certificate signed by the higher level authority, and you become kind of authority for your more specific namespace, like for prefix CA or other prefix CA. And all kind of exchanges are based on these very basic naming conventions. And I will try to go over the exchanges in very, very rush fashion using this kind of very trivial example. So let's say there is some certificate requester trying to get a certificate. So okay, I highlighted in here. There's a 1, 2, 3, 4, 5. Cannot count. So there's a 5 types of request responses defined by the NDN Cert. Some of them are mandatory, and several of them are like probe and validated are optional things, which depend on a specific CA. And there's one more thing that we actually added recently. I forgot, but I cannot talk about this yet. I forgot the details. So in some cases, the requester may already know what the namespace is being assigned and in which namespace that requester is supposed to request certificate. Like, for example, so after the bootstrapping process that we talked in last 2 NDN calls, so the device would already know the namespace and simply needs to generate a request towards the authority, including that request as part of the. Okay, so there's more requests in my statement. So generate interest that incorporates the self-signed certificate as part of the request, and which the overall request is signed by that private key corresponding to the included public key, effectively. And so that would be new is a required stage, which will create some state at the authorities side, and that state or number of that state will be returned back to the requester. And the second step would require several challenges, or picking and conforming, or not conforming, performing at least one challenge. So currently we have defined 4 listed challenges, and some of them still under development and some of them still under definition. So the simplest one is the pin code challenge, which just requires some form of out-of-band access to this secret pin code that is being generated by the authority. There is a device secret is again out of band access to shared secrets like a pin code, but this one is either requester generated or somehow so kind of the device already knows that code, and authority also knows that code. So this device secret is very closely related to what we have talked during NDN calls. There are a few more. Is a credential based, is a kind of, in some cases, if you have another certificate issued by another authority, you may want to get, or you may be allowed to get a certificate in a different namespace. So that was, I think, a current example with the OpenM Health. I forgot the details, but given the NDN either in NDN testbed certificate, presenting a valid NDN Cert certificate, you can get the OpenM health key, or vice versa. And email-based, I guess you're all familiar with the current testbed certificate model. So for the selected, so there are two other steps, kind of one semi-optional, and on this picture I'll show you where they actually required. It's a select. Okay, so this one selects a pin code challenge. So effectively, the requester sends a simple interest that has a naming convention CS select, identifying the request ID and identifying the that I want to select the pin challenge, and including this signature. I mean, this is all command interest. Like we just decided not to put nonce, timestamp, signature info, and signature value. So those are part of this sig set. After receiving that interest, the authority first validates whether that request came from the same party who sent the original request, because that CA would already have the public key, and this public key will be associated with the request ID. If everything is fine, it will generate internally some pin code and just respond that it is waiting for the code. Then there's some magical out-of-band process of this camera to figure out what is the pin code and send additional message, kind of validate, including this generated code to the authority. And if everything is fine, then the authority will respond that the certificate has been generated and can be downloaded. There is another case where the validate may not be required. So, for example, in the case of this device generated or requester generated secret, that secret already known when the device is sending the select request, and it can simply include either encrypted version or some HMAC protected version of that secret as part of the select interest. And in that case, the authority can directly respond that the certificate has been generated. There are a few additional stages because the certificate may not be generated immediately because it may, like within the current testbed, the authorities actually need to do some additional verification of the request. So we also added the concept of the status, and I think I may mess up the title. So requester can periodically send the status request, which looks very similar to validate, and you just, again, the same naming model is just the name of the CA, status, and name of the identification of the request, and the whole thing is assigned as a command interest. And as soon as that request that certificate has been issued, the requester can download that certificate by literally issuing this download command. So for this one, we decided not to have a command interest, just a simple non-signed interest that just downloads that certificate, because it's a public information and nothing really secret to hide. And the return part is encapsulated as part of this response. Okay, a little bit over time. So there is a special considerations regarding intra-node app certificates, and there is actually, I think, one more additional step that NDN Cert that we're trying to accomplish with NDN Cert is to not just validate the request and all those pin codes, but rather also validate that a request is coming from the legitimate application, like it was from the trusted developer, for example, and that the request is coming from the specific application instance that the user actually controlling. and because there could be cases of multi-user systems when there's some other application requesting, and you don't want to mess up those things. Okay, I'm not going to go in detail. And so this is the status. Oh, different status. So this is the code, the kind of pointer to the code base, which includes the whole framework and the libraries. We have a command line client and command line server and client. Doing the very basic operations. We still yet to do port of the existing NDN Cert named data.net system. I asked G and he gave me this timeline, but I hope we can do it earlier than this date. We'll try. So we need to add the NDN Cert ID Manager support as part of the Android. So this is what Haitao was asking questions about. And similar things, this is optional, but very, very important to add similar support in macOS and Linux as part of the NDN Control Center. Okay, so that would be my last slide. And I hope
so for the internode, so the last second slides, for the internode protocol, so where can I find the details here for this one? Yeah.
G, you can torture him.
Okay, thank you.
Yeah, there's no document for this yet. Maybe it's only in the poster abstract.
And I thought you were writing the wiki for that.
Right, I'm working on that. Yeah.
So G, you said you're working on that. So when will this be ready? So to implement the identity manager into NDN Android, actually those details are needed.
Actually, we don't need this we don't necessarily need these verifications as part of the Android system, because this, we maybe need to add a little bit specifier here, because the important part for the why we need this is because some systems are multi-user, and you can run multiple instances of the same application. Luckily, Android, you can run exactly one instance of applications, and all there's only one user, and all applications are by definition verified. So we actually can run just directly normal NDN Cert protocol without worrying about additional verification. So don't get blocked on that.
I don't mind the short term you can get around, but I think the longer term it's probably good to have this checking.
If it makes sense, yes. So the current thinking was around the desktop systems. I haven't thought yet about whether it makes sense in Android system at all, or if it makes sense, how it can be done. Okay, so I hope that from this seminar you had a good idea of the new certificates, so that we have new certificates, they have new names. It's not a disaster. I mean, a little bit disaster, but not major disaster. We need to, for the application, we need to modify a little bit the validator configuration files. Those should simplify things. For certificate management, so as of right now, you can create keys and create certificates using command line. If you're brave enough, you can try NDN Cert server and client just on different machines, but again, you will be running both client and the server. We will try hard to deploy the system so you can easily get the certificate from the centralized system, and this should be up and running before we do the deployment of the new version of NFD and NDNCXX on a testbed. So I will block on this part.